So in today's video, which I hope is going to be under 5 minutes, I'm going to put the final touches on a Luxman R-341 stereo receiver. I'm going to adjust the idle current, which should go real quick. There wasn't really too much wrong with this receiver. Noisy pots, and that's about it. For those of you who don't know, Luxman is an old company. They've been around since 1925, and they've generally been known for more high-end and, well, expensive equipment. They're from Japan, and I think they first came to the United States in 1975. That's when their first models were introduced. Now, I think this unit here, this is early 90s or something like that. Normally, I try to stay away from units that are 90s and newer. I prefer 60s to 80s, but that's just the way it is sometimes. And with the idle current, what I have to do is I have to let the unit warm up. So I'm just going to let it run for 10-15 minutes. So in order to do the idle adjustment, I need a DC voltmeter. And I need a little screwdriver like this because I'm going to be adjusting a little pot. And I prefer ceramic instead of metal, just in case you slip. So I let this unit warm up, and I put the volume control all the way down, because what I'm doing is I'm adjusting the idle current already, as the name says. That doesn't mean half throttle or full throttle. That's kind of like a car, like I always like to say. That's in the idling position. So once this is warmed up, then I can go ahead and make the adjustments. There's one basically for each channel. Basically what I'm doing is measuring in between one of the final output transistors for one channel, and that transistor has a emitter resistor, and I'm measuring across that basically. And then I do the same thing for the other channel. You can kind of see what I'm doing right here. My finger here is touching this resistor, and I've got probes hooked up across there. Also, best to use probes where you can't short anything out either. Let me go ahead and show you my probes real quick. Let me shut the unit off for a second. Okay, these probes look like this, these little grabbers. These are what I like to use, that way I don't short anything out, or at least I shouldn't. So let me go ahead and shut the camera off for a second so I can get this thing back on there, because this might take a while from this angle. Now, I wasn't able to print the service manual out because my printer just started acting crazy, but I just want to show real quick what I'm doing here. And I'm measuring between test point 1 and test point 3. I would scroll down in the schematic, there would be a test point 2 or test point 4. And if we look at the configuration here, this is what's called an emitter, basically an emitter follower. The output signal is taken across the emitter. Also, if you notice, it's dual supply. So one side will be exactly like the other side, but the polarities will be different. And you can see we have a NPN transistor and a PNP transistor, and say the sine wave is fed to both of the bases here, the base of Q17 and Q515. So if say we fed in the positive half of the sine wave came in here, that would mean this transistor would turn on, and this transistor would be turned off because the positive basically signal is coming in here. Now, on the next half of the sine wave, this here will go, the input will be negative, and this will turn on, and this will turn off. They complement each other. So I think back in the day they used to call this a dual supply, complementary, symmetry, basically amplifier, and symmetry basically meaning that both sides are the transistors to be matched and the resistors and everything else to be matched. and complementary because they basically complement each other. So now back to the actual unit. And we can see what we got here on the unit. It's 9.2 millivolts, and I think I'm supposed to bring it down to 2 millivolts. Of course, we don't want it too basically too low, and we don't want it too high either. Basically, we want what the manufacturer calls for because they know best. So I have to point out again, like I mentioned earlier, you have to let these units warm up, kind of like warming up a car. And then you can go ahead and do the adjustments. So right in front of, you can't see it down here, I don't think I can show it. Right in front of this resistor here, there is a potentiometer pretty close there, and I'm going to go ahead and adjust that down to 2 millivolts, and then basically do the other side. The other side though I won't do on camera, I'll do it off camera because I don't want to bore any people here. So let me go ahead and make the adjustment real quick. So I have been adjusting this channel, and that's about the best I can do. It is somewhat lower than it was earlier. So I'm just going to go ahead and leave this at that. Again, we don't want it to be too low. We want a little bit of the transistors to have a little bit of bias, but we don't want the idling current to be too high either. We don't, kind of like, again, like I always say, like adjusting a car, you don't want a car idling at 2,000 RPM, but you don't want it idling at 200 RPM either, so it stumbles when you hit the gas. So it's kind of a loose analogy, but it kind of works. So we're going to take one more quick look at the schematic. I think I mentioned earlier that this was a emitter follower circuit, meaning that, for example, if we had a positive waveform coming into the base, we would get here a positive waveform coming out. The signal is taken across the emitter. And of course, we had a negative coming in down here, we would get a negative out. It's not, for example, like a common emitter circuit. Say if the output's taken off the collector, if you have a positive in, you're going to get a negative out. This doesn't change basically polarity. And anything else I want to mention? Yeah, I think I'd mentioned idling current. Well, that could be figured out if one had to, simply by taking Ohm's law. I know this resistor, for example, that I had the voltmeter hooked up to, it's 2.2 ohms, and I was supposed to make the adjustment for 2 millivolts, and all I would need to do was take I equals E over R, and then go ahead and figure out the current. But that's not called for in this case. That's also unnecessary. One last thing before I forget, and it's not really electronics related, it's more anecdotal. When I talk about the Luxman company, believe it or not, I think they originally started out with making picture frames in Japan, and then they went to importing radios and stereo equipment, and then they started making their own. That's all I have to say. Thanks for watching.